Hi, chemistry students. Let's talk about an idea called resonance structures. In essence, an example will show best what they are, but it comes down to this. Sometimes we can draw the same molecule with multiple Lewis structures, and we imagine that the molecule then is not any one of the Lewis structures, but something kind of in between. So we say that there's kind of a resonance, a moving and mixture of all of these things at once. So let's see an example, and that will set us in motion for understanding more about resonance structures, and then in class, possibly even learning how to determine the best Lewis structure for a molecule when there are resonance structures. Can be done sometimes. So let's look at ozone to begin. Here's ozone. And when I draw ozone, I would imagine that I have an oxygen in the center, and I'll just put its 6 electrons in this format because I know where I'm going with it. And then I'm going to imagine it needs 2 electrons to get to 8. So I'm going to say that there's going to be another oxygen right next to it to the right. And this oxygen, it will donate 2 electrons in such a fashion so that it sees 8 and the oxygen in the center sees 8. All right, so there's still a third oxygen to go on there, but these all of the 2 that are shown both obey the octet rule. So any new oxygen would come on, and it would not bond with a double bond, but a single bond. In other words, we would get this fashion, this Lewis structure. But we drew the picture before, and we allowed the oxygen that has the little X's for electrons, we allowed it to double bond. But why couldn't the oxygen with the little open circles double bond and the other one do the single bond? I mean, we could imagine this. We could imagine that these electrons could move there, and that these electrons could move there, and in doing so, the double bond would move from the right-hand side to the left-hand side. So that's physically what might be happening. Or we can just imagine that some people in the room would have drawn the double bond to the left. There's no reason to draw it to the right. It would look like this. Oop, that's a pretty ugly oxygen, but that's okay. So while my artistic skills aren't great, we can still get the point across that we could have drawn it a different way and obtained this correct, equally correct Lewis structure. Neither one of these is better than the other. As a matter of fact, neither one is probably correct, but neither one is possible, but both are probably correct. It's kind of an odd thing. Quantum mechanics says all these possibilities are there, and there's no way to know where the electrons are. We'll learn later a better picture of this, which will help us out in understanding what resonance is. But for now, all we know is that these are resonance structures, and they represent the fact that we can draw different Lewis structures for the same molecule. To show these properly, there's a little shorthand which allows people to display that they're talking about resonance structures. You would draw your structures in this way. So we would draw one of the Lewis structures, and then we would draw a double-headed arrow, and then the other. So that's what we're talking about when we're saying resonance structures. An important note, we're not rotating the molecule, we're not changing the shape of it, we're not changing anything like that. We're just moving where the bonds are. So all the nuclei are staying place. This would not be a resonance structure. This would not be a resonance structure, what I've just drawn, because it changes where the bonding's happening, not what kind of bonding is happening. So the only thing that's allowed to move during a resonance structure is the electrons, not the nuclei, not the atoms, not the symbols that we're using. So we'll pick up from here in class. Hope you understand a little bit more about resonance structures.